Hi to all. I am A.V. Laxman Rao, Assistant Professor in Physics Department. In today's session, I am going to explain you about the classification of materials as conductors, insulators, and semiconductors. Okay. So the overview of my session is, first I am going to explain about the properties of conductors, next insulators, and the semiconductor properties, and overall I am going to compare the properties of conductors, insulators, and semiconductors at last. Okay. Now here, what are conductors and insulators and semiconductors? All these three are materials only that we know. Okay. Now how we can differentiate these three materials as three different types based on some criteria. The criteria that what we are following here is electrical conductivity. Based on materials electrical conductivity, or we can also say that based on the energy band gap of the materials, materials are classified into three different types as conductors and insulators and semiconductors. Now here the question is, what is electrical conductivity? We are differentiating the materials, we are classifying the materials based on electrical conductivity. Then what is electrical conductivity? It is the ability of that material to pass the electrons. How freely electrons are going to be passed through that material. Based on that criteria, we are classifying the materials. Even we can say that what is energy band gap? It is the gap between the conduction band to valency band. Based on energy band theory, also we can classify the materials as the same. It is nothing but as conductors and insulators and semiconductors. Okay. Now here first let me take the properties of conductors. Let me take the properties of conductors. Which materials are called conductors? First we will see. Those materials in which electrical conductivity, as I told you, electrical conductivity is the main criteria. Based on that criteria, we have classified the material. That's why based on that electrical conductivity, the amount of electrical conductivity in these materials, we can expect that electrical conductivity is very high. Very high electrical conductivity these materials will have. Okay. Now let us discuss about the properties of these materials. The first point is those materials in which electrical conductivity is very high, such type of materials we are calling as conductors. Okay. So electrical conductivity, we know that we are representing with a symbol that is a sigma. Okay. And you know the units also for the sigma, that is per ohm per meter we are writing. Okay. Now if you look into the properties of conductors, the first property we can say that this electrical conductivity is very high in these materials because of a large number of free electrons are available for electrical conductivity in these materials. Very important point here is a large number of free electrons. Already we know that if more number of free electrons are available, then more electrical conductivity can be expected. Any material's electrical conductivity decided by two factors that we know. First thing is availability of the free electrons. More number of free electrons are available here. That is the first criteria. And the second one is mobility of these free electrons also are deciding the electrical conductivity. In conductors, it was observed that it will have a large number of free electrons. And when we apply electric field, when electric field is applied on these materials, then it was observed that all these free electrons are drifting. It is nothing but they are experiencing the force in a direction that is opposite to the applied electric field. It is nothing but you are applying electric field in this direction, means the force is experienced by these materials, these free electrons in these materials in opposite direction. Due to that drifting force, all free electrons are moving in a same direction. So the velocity vector is becoming as a very high value. The result of that is conductivity is present in these materials. And very important thing is, if electrical conductivity is very high, if electrical conductivity of any material is very high, we can say that that resistivity of that material in general will become as very low. Here resistivity can be represented by a symbol that is rho we are calling. Okay. Here we are representing the conductivity as sigma symbol, and resistivity we are representing with a symbol that is rho. Okay, and units are here ohm meter. We are writing units for this are ohm meter we are writing. Okay, so ohm meter is nothing but the units of this resistivity, which is reciprocal of the electrical conductivity. Reciprocal is nothing but 1 by, as like that we are taking for resistivity. That's why we are getting the units as ohm meter. What is resistivity? It is nothing but the opposing force to free flow of electrons is nothing but called as resistivity. When electron is trying to move freely, then something is opposing the free flow of electron. That is called as resistivity. In these materials, we can say that the resistivity is very low in these materials, since electrical conductivity is very high. Okay, and if you increase the temperature, another property let me take as the temperature. If you increase the temperature of these materials, what about its electrical conductivity? Will increase or decrease? Obviously, we can say that electrical conductivity will decrease. Why it's so happening as electrical conductivity is decreasing? Because of when you apply the temperature, when you raise the temperature of the material, then all free flow of electrons are start vibrating. Instead of moving freely, they are starting vibrating. Due to that vibration, free flow of that electrons will not be there. Due to that, some disturbance will be happened in the free flow of these electrons. The result of that is here conductivity is going to be decreased. So that is the reason why when we increase the temperature, electrical conductivity of these materials will decreases. Okay, and very important thing is here, what about the energy band structure of these materials? Why? Because based on energy band gap also, energy band structure also, we can classify the materials into 3 different types that we know. If you look into the energy band structure, this is the energy band structure of these materials. Energy band structure means what? We are taking the higher energy band as conduction band here, and the lower energy band as the valency band. And in general, we are saying that in conduction band, free electrons are located. Now, if you take as like this, in these materials, a large number of free electrons are available. All these electrons are occupied in this conduction band. If free electrons are available, then they will occupy in conduction band. And valency band is the band which is corresponding to the bonded electrons. It is nothing but minimum energy, as like that we are taking. But whatever the available electrons are there, all they are here the free electrons only. Due to that, conduction band is completely filled with free electrons, as like that we can say. Now, if you look into the energy band structure of these materials, conduction band is completely filled, whereas valency band is here completely it is empty with free electron. No free electrons are available here. No free electrons are available. Whatever electrons are there, they are all the conduction electrons only, free electrons only. That's why in these materials, we can say that conduction band is going to be overlapped. Conduction band is going to be overlapped on valency band. Here, if one band, upper band is here, it is overlapping on the valency band, then there won't be any gap. That's why the energy gap in these materials, we are calling it as here, saying it as it is 0. Gap is 0. It is nothing but conduction band is overlapped on valency band. Okay, so that's why this property is very, very important. Valency band, conduction band. If you look into these, conduction band is overlaps on valency band. Due to that, the energy gap is becoming as 0, and high electrical conductivity values these materials will have. So, such type of materials examples can be taken as here copper. Best example is copper. We know that if you try to pass the current in copper wire, then simply the current will flow. It is nothing but copper is an best conductor because of that reason. Means free flow of charge carriers, electrons can be seen in copper. Okay, not only copper, there are some materials are there as iron also is the best example. Aluminium also and silver also, like that we can take. So we can say that conductors are nothing but here the metals. Any metal can be taken here as the example, and we can say they are all nothing but the conductors, as like that. So these are all nothing but the properties of conductors based on the electrical conductivity, or we can say that based on the energy band structure. This is energy band structure. Okay, so we are plotting here a graph that is nothing but conduction band is taken as the higher energy level, and the valency band is taken as the lower energy level, as like this, and we are saying that Eg value is becoming as 0. So this is the property of very important property, Eg equal to 0 for the conductors. Okay, now if you move to the insulators, the properties of insulators are quite opposite when you compare with the properties of conductors. So whatever you are writing there as the properties, if you write in opposite, then they were nothing but the properties of the insulators. So here let us see how we can justify that statement. Now those materials, insulators, which are called insulator, those materials in which electrical conductivity is almost 0. Whereas if you take the conductors, electrical conductivity is very high. But here in these materials, opposite property is nothing but almost electrical conductivity can be expected as 0. Okay, and if you look into the other properties means what is the availability of free electrons. Here if you look into the free electrons, number of free electrons which are available, here we can say that no free electrons are available, whereas in conductors a large number of free electrons are available. But in these, no free electrons are available for electrical conductivity. If free electrons are not available, electrical conductivity will also become as 0 only. Okay, and whatever, if free electrons are not there, then what about the electrons which are present in that material? Whatever the electrons are there, they are all nothing but the bonded electrons. It is nothing but orbit in which that electrons are revolving around the orbit. They were bonded with the nuclei itself. Strong bonding is there between the nuclei and the valency electrons itself. No free electrons are available. When valency electron is excited, then only it will become as the free electron, that we know. So in these insulators, free electrons are not available, and whatever the electrons are present, they are all the bonded electrons only, as like that we can say. Okay, next, when we apply electric field, will the electrical conductivity is present in these materials? Like that, if you question yourself, then we can say that no conductivity is present. Why? Because even though if you apply the high electrical conductivity, high electrical field also, electrical conductivity cannot be expected in these materials, since the bonding is very strong between the electrons and the nucleus. If the bonding is very strong, never become that bonded electron as the free electron. If free electrons are not available, obviously we can say that electrical conductivity is 0. If electrical conductivity is 0, what is the thing that can be expected? Means high resistivity they will have. Conductivity is almost 0. It is nothing but high resistance these materials will have. Okay, and if you take the electrons can jump from valency band to conduction band unless until you apply energy that is greater than the 10 electron volt. Then only few electrons can be expected to be jump from valency band to the conduction band. But it is almost, we can say that it is impossible for these bonded electrons to become as the conduction electrons. Okay, so that is very important property of the insulators. Okay, and if you take the energy band structure, this is nothing but the energy band structure of insulators. Here we can say that here this conduction band is completely empty, since we know that in conduction band free electrons are located. No free electrons are available for electrical conductivity na. Because of that reason, conduction band always can be expected that this band is completely empty, and whatever the electrons are there, they are all here the bonded electrons only, which will occupy the valency band. So valency band is completely filled with bonded electrons, and conduction band no free electrons are available. Due to that reason, here we can say that the gap between them is very high. So energy band gap of these materials is, that's why we are saying that very high, and approximately in insulators this energy band gap value is 10 electron volt can be expected. So due to this reason, electrical resistivity of these materials is very high. Okay, and we can say as an final conclusion of these insulator properties, as insulators are here bad electrical conductors, as like that we can say. Okay, and what are all the examples of such type of materials in which resistance is very high and the conduction, electrical conductivity is very low? We can say so many examples. Among them, the very important and a few examples can be taken as rubber can be taken, and wood can be taken, and paper can be taken, etc. Like this we can take so many examples for insulators in which electrical conductivity is almost zero. And very important property of these insulators is energy band gap in these materials is very high. And when you take the conductor's energy band gap, it is very low and it is almost zero only. So the properties point of view, both will have the opposite properties. Okay. Now let us move to the third type of materials. Here these materials are called semiconductors. Semiconductors in electronic field, electronic devices, most of the electronic devices, almost we can say all the electronic devices are here manufactured by using the semiconducting materials only, since they have some unique properties. The most important unique property is their properties lies between the conductors and insulators, in between. That's why they were called as semiconductors, we are calling them as. Okay. Now if you take the definition of semiconductor, how the materials are defined here, those materials in which electrical conductivity is partial in nothing but semi, means when you compare with the properties of the conductors, electrical conductivity is very high na, insulators conductivity is very low na, in between if any material conductivity is there, then the such type of materials are called insulators. We are calling them as semiconductors, we are calling. Okay, and here now let us discuss about the properties of these semiconducting materials. Now very important thing is insulator properties are in general can be expected as between the properties of conductors and insulators. And very important property of these insulators is their properties are dependent on temperature. Temperature sensitive properties they will have. Temperature sensitive properties means slight increase or decrease of temperature of these materials will drastically change the properties of the materials. How we can say that? One best example let me take. Here the example is when you take in semiconducting material whose temperature is 0 degree Kelvin. Temperature of the semiconductor is 0 degree Kelvin. Then all the electrons whatever are there in that semiconductor are called as the bonded electrons only when temperature is 0. That's why the semiconductor is going to behave as a perfect insulator. No more it is called as a semiconductor. We are calling that material as here insulator. That is because of the temperature. When temperature is 0, all the electrons which are available, they are all bonded electrons only. Covalent bonds are completely are there between the silicon or the germanium to germanium. That's why no free electrons are available. Hence that material is going to behave as a perfect insulator, like that we are calling. So temperature dependent properties these materials will have. Now the thing is, okay, temperature is 0, they are behaving as the insulators. When I increase the temperature of the materials, then what is going to be happen? Covalent bonds are going to be broken. Due to that, free electrons are going to be available in that conduction band. The result of that is conductivity is also go on increases as the temperature will increases. So that is very important thing. Means conductivity of semiconductors is in our hand. We can control their these materials electrical conductivity by increasing the charge carriers. Charge carriers can be increased by increasing the temperature, or another way is by adding the dopants to that semiconducting material, charge carriers can be increased. So overall we can say that semiconductors electrical conductivity is in our control, controllable That's why these materials nowadays we are using in electronic field to manufacture the devices which will work according to our applications. Okay. Now, energy band structure of these materials we will take. Energy band structure of these materials, if you take in conduction band, we know that conduction electrons are there. In valency band, valency electrons will be there, and it is nothing but the bonded electrons, and the gap between these conduction band to valency band, which is called as Eg, in these materials Eg range is 0.7 electron volt to 1.1 electron volt. 0.7 to 1.1. You see, you compare this value with the conductors and insulators, it is neither 0 nor very high. In between it is there. So, if you take an example as a pure silicon or pure germanium, if you take pure silicon, if you take, the energy band gap is 1.1 electron volt. If you take pure germanium as a semiconducting material example, then its energy band gap is 0.7 electron volt can be expected. Okay. So, that is very important that we need to note down here. Okay. And when temperature is 0 degree Kelvin, as I told to you, here no free electrons are available and all the electrons are bonded electrons only. That's why that material is going to behave as an insulator. That is very, very important. Temperature dependent properties these materials will have. Okay. And overall, if you take, the resistivity of these materials is neither very high nor very low. That is in between 10 to 107 ohm meter will be there. Okay. So, these are all the properties of semiconductors. In general, we are using semiconductors in electronic field to manufacture the different electronic devices such as diodes, LEDs and ICs, microprocessors, microcontrollers, all they were built with the semiconducting materials only. Now, if you compare the three different types of materials, very important one based on the energy band structure, we can say that in conductors, if you take the conductors, in conductors energy gap is 0, in conductors energy band gap is 0, and in insulators energy gap is very high, and in semiconductors this energy gap value is in between this insulators and the conductors at 0.7 to 1.1 electron volt, like that we can say. So, based on the energy band structure, if you take the three materials and compare, then this diagram is clearly explaining what is the difference between them as like this. Okay. So, next one is conclusion. Let us move to the conclusion. Okay. So, first one we can say that here conductors, if you take, will have high electrical conductivity, and energy gap value in conductors is also, we know that it is 0. And if you take the insulators, electrical conductivity value is almost 0, reverse property, and Eg value is high, as like that we can say. If you take the semiconducting materials, electrical conductivity is neither 0 nor very high. In between it will be have, and the Eg value is also taken as the medium value. Minimum, it is nothing but neither 0 nor very high. In between value is present in the semiconducting materials. And very important thing is, in semiconductors, here the properties of these materials will change with respect to temperature. Temperature dependent properties they will have. So, like this we can conclude this session as. Okay. Thank you.